you know a point?
Point gradient.
Do you know a point?
Intercept point.
Do you know an intercept?
Can't draw them.
This is probably the hardest example.
Oh, great.
Can we rearrange them?
Well, I can answer.
Would that help?
I don't think we...
Sure, let's go for it. Let's rearrange them.
Dead point. No. No point.
Rearrange. I'll move all of that to the right-hand side and end up with tell me if that doesn't make sense.
Hold on, I'm still writing them down again.
Hang on.
Why
That
is...
helps me.
That's fine. It does help. And this one, I'll move it across and divide it, so it's going to be like that.
Okay, so... Yep, still...
Yeah.
Still, well, you've got the right first step. What are we trying to prove here for there to be no solutions?
That the gradients are the same.
Gradients are the same. So, well, what's the gradient of the first line here? What's the gradient?
M minus 2.
Is it just that?
No.
No, it's M minus 2.
It's m minus 2.
So that one.
What about that negative sign?
No, it's negative and minus. Yeah, it's negative and...
Negative m, so it's the whole thing. Whatever's multiplied to x is the gradient, isn't it?
Yeah.
So we'll call this m1 is that. What's the gradient of the second line?
M.
M
M
over 2. It's the whole thing. Whatever's been multiplied to the x is the gradient.
Isn't it? Do we substitute that into that one? Is it negative? M over 2?
Yes, you're right. I've moved that across, so that should be a negative, shouldn't it? Good pick up, Uli. So what was I trying to prove again?
Same gradient.
Same gradient. So I'm trying to prove that
equals M2.
m1 equals m2.
So M,
Substitute M2 into M1.
negative M minus 2 is equal to negative M over 2.
Ah, right. So if I prove this, or I find out whatever number that makes this true, that will mean there are no solutions for that value of m. So how do I go about simplifying this?
Wait, say what you just said again.
What's the next step to finding m?
Times by 2.
Times 2.
Oh.
So that's going to give me minus 2, m minus 2 equals minus m. Now what?
Wait, what?
Expand the brackets.
Expand the brackets, so minus 2m plus 4 equals minus m.
Don't we only need times by negative?
And then you need to times it by a negative to make all the m's positive. And then you need to move you either need to move the m or the negative 4.
Which way? Let's move the m because that means that I have to move the other one.
Yeah, the 2m. So you need to minus 2m over to the other side.
Minus 2m, minus 2m. So I end up with minus 4 equals minus m.
And then you
Are
need
you regretting your decision to multiply by a negative now?
Yeah.
What are you just doing?
Hold on,
Do it again.
so
Divide by
confused.
negative 4.
Divide by negative
Huh?
1.
M equals 4.
Don't listen to me.
M equals 4.
m equals 4. If the opposite of m equals negative 4, then m must equal positive.
do that in your head.
Yeah.
That is actually my question.
What?
How do people do that in their head?
I reckon I probably got that.
No, well, because
Or they followed some unorthodox method.
And that's not unorthodox?
4 take 2 is
No, this is
2,
highly orthodox.
divided by 2 is also 2.
I can't even understand my
Right,
own
so-
notes.
Base knowledge for you guys. This was what you were trying to prove. Did it help that you rearranged into y equals?
Yeah.
Yep. Why?
Because they look the same.
They look the same and you can clearly see the gradients, can't you?
Yeah.
Yep. So are you starting to see now why I told you at the start that I would advise going through that step?
Yeah.
If this whole thing is about gradient, it makes it very easy to see. Gradient is just that section there. Alright, that should be your first step. Second step was to go back to what we're trying to prove. The two gradients are the same. And then we can just substitute. We know that they're labelled like this. We just put that in place of that one in place of that. And we simplify and solve down to one value of m equals something. Alright, so now we've got 0 solutions when m equals 4.
Is that the easiest way you would have written down that?
Yep.
Oh,
It is?
God.
Yep.
Alright.
So you have one solution for every other m.
Now, hold on a second.
Uh-oh.
What else do we not know?
Okay.
Why?
The y
The y-intercept. So it's
K equals
that needs to go back into there, doesn't it?
Oh, well that simplifies everything then, doesn't it?
Yeah. Don't everything needs.
K would equal to 1 because the y-intercept is K over 2 and 2 is the y-intercept, so it's just 1.
So,
What?
It's just 2 over 2.
no. So, think about this. These are your y-intercepts, aren't they?
Yeah.
Yeah.
We can follow the same process and we do this. Alright? We need them to be not equal, don't we?
Yeah.
Alright, so if we have 2 equals k over 2,
Well then,
what should k not equal?
2.
Times 2 here, times 2 here, so 4. So if we say that k does not equal 4, that will mean that we've met the criteria up there. C1 does not equal C2. Right? Because don't forget that the C value in the second one had to be divided by 2 before you could read it. Sorry, the k value.
I'm so lost.
Yep, same.
So, did the gradient part make sense? 2 gradients had to be the same,
Yeah.
so we just equate the gradients.
Wait, so why don't we just decide that k over 2? What?
Look, Annika. Criteria.
Yeah.
The C values may not be the same.
So we just decided that they're not the same.
They have to, if there's no solution, they have to be different, don't they?
But they're.
Alright, so I take C1 from the first equation, which is 2. C2 from the second equation, which is k over 2.
Oh, okay.
Right?
Still doesn't-
They cannot be the same number. If they are the same number, this is the case here. If they're the same number, they have the same equation, which means that there are infinite solutions. If they are different numbers, we have no solutions, because the gradients were already the same. So I have to move one line up or down.
So are we just saying if there were no solutions, k couldn't equal?
That's right.
Oh, that makes so much more
Yep.
sense.
So for there to be no solutions, m has to equal 4 to make the lines parallel, but k can't equal 4 because otherwise the lines will be the same line. That's it.
Okay.
Alright? So then, what would happen, or how would I find infinite solutions? What would the m and k values be for infinite?
The K could only be 4.
K would be the same, wouldn't it? M equals 4 to make them parallel, and then I'd make the y-intercepts the same as well, so that the 2 lines are on top of each other.
but the y-intercept in the first equation is 2.
Yep, but what's k?
Well, don't worry.
Divided by 2 makes the y-intercept. So k has to equal 4 for there to be infinite solutions. Alright? What about one solution? Sorry, one solution.
The gradients have to be different.
Gradients have to be different.
Exactly.
So what would the gradient have to be? What would m have to be?
Anything other than 4.
Anything other than 4. Good work.
I'm really bad at this.
Same.
I
It's
keep
a
thinking.
very new idea.
Oh, I keep thinking.
Wait, hang on, wouldn't you write it, wouldn't you just write it, you'd have to change it to M1 and M2 because even if oh wait,
No,
is it
M2.
I know what you're saying, but because the initial variables were m and k,
yeah.
that's all we're interested in. We simplified it out to make m1 and m2 to help with the process, but the end result is to go back to the variables we were given and state the answers in those terms. Right now, this is a hugely new skill. Alright? Remember, simultaneous equations is not new, it's this overlay here. And this thinking is quite high level because it's not thinking of let's just find the intersection point. It's interpreting all this information you're reading. Alright? So you have to go back to your base. You go, first of all, I'm trying to find the gradient. Alright? Then I'm trying to interpret it. So these 2 statements here will help you interpret it. If this happens between 2 equations, there are no solutions. If this happens between 2 equations, there are infinite solutions. And if that happens, there is one solution. Alright, so it's all about interpreting what the gradient and y-intercepts are telling you. Alright? Now, I'm going to leave that on the board. Copy it down if you need to. This is the key information that must go in your book so you can refer back to it.
What's this topic called?
This is called perpendicular, not perpendicular, simultaneous equations in set 2. There was also simultaneous equations in set 1, which is just basic, find the intersection point. This is now simultaneous equations to interpret parallel and perpendicular lines. Yep.
I don't get
This one?
Yeah.
Okay. So look at this example here.
Yeah. Oh,